All right. Hello, everyone. Welcome back from the coffee break. So, as people are kind of trickling in, we have a few announcements. So, first, we'll shout out our silver sponsors and then move on to the next activities. So if you're interested in using other languages in combination with your JavaScript code, there's a discussion room happening now, and you can attend that either remotely or in person by going to the balcony over there. And yeah, join it in Spatial Chat if you're online. And with that, I will introduce our next speaker, who's actually the first speaker that I'm announcing who's living in the Netherlands. So very excited to have some local representation on stage. So Jorrik is a creative front-end developer, meaning both like creative is in like what you see on the screen, but also in how you think and solve problems. And I think he's wearing the perfect shirt for that. And I think this will also be really evident in his talk about creating AR face filters with the Chrome face detection API. And while Jorrik is so approachable and easy to talk to, if you want us to answer your questions on stage, please go to Slido during the talk and enter the code 0106, and then make sure you're on the residence track, and we will be sure to try to cover them in the Q&A afterwards. And also you can upvote different questions if you see one that you're like, yes, I want that. And with that, Jorrik, the stage is all yours. Please give a warm welcome.
Thank you, Caroline. So let me put my water here. Welcome. My name is Jorrik Klijnsma. As Caroline said, I'm a creative front-end developer, and I'm going to share something about the Chrome face detection API. It's a mouthful, but managed to say it okay. So I'm a front-end developer, and I work for over 6 years as a front-end developer now. The last 2 years at a company called Ordina. And what we have, we are developers. I think most of us are here. And developers come with some kind of image. Sometimes we are a bit like nerdy, and but we are also problem solvers. But there's also this shift changing where code can be fun, and also what you create with code is more and more often seen as fun. But the code part is still boring. And that's where sometimes there is this interesting thing where you also want to create no boring code, but also not the great end result. So maybe people can show hands if you have seen boring code somewhere in your life. Yeah, I think most of us have. Or have you seen code that's not boring and was more interested? Maybe also raise hands. So maybe a few less, but still there. And the last question, maybe people have seen code that was not functional at all, but was purely for fun or fun purposes. So also some hands over there. With the recent years, there are these all kinds of developments. AI is introduced into the scene. There are more demanding users. They are expecting more and more features. And you have the problem with maybe not being noticed if you don't have these amazing features in your app or service or whatever. So you need to be divergent and show what you can do and what's possible. This Chrome face detection API, it's something that's behind the feature flag, meaning it's not usable right out of the box. There's the process for this shape detection API. The Chrome face detection API is part of that bigger shape detection API. It includes text detection and also barcode detection. And the barcode detection is already done. It's ready to use for everyone. But that face detection and text detection are still being developed. For this, it's an important note that the face detection does not mean face recognition. So it detects your face, but is not able to recognize a face from this is this person, or that's that user logging in. So it's only showing there is this face on this type of media. So how do you enable the Chrome feature flag? So there's this link. When you open this, let me try if it works. No, it needs to open. Let me copy paste it in then. It's not a valid normal link. Choose application, and then show options. You're not seeing this. I have to select the Chrome for it to open. Google Chrome browser. So over here, let me slide it over. So now it should be visible. This is the part, if you open that URL, you are seeing this experimental feature thing, and you just need to enable it. It comes with some other features as well, so keep that in mind. Recently got some trouble with selecting, for example, text on GitHub, which is not showing properly, so that's also seemed to be part of this something buggy going on in this web platform stuff. So that's how you enable this feature, like this. That was way easier. So now you have enabled it in your browser, and now you can use it. To use it, you start to call a new face detector. It's just simple as that. It can handle two properties. It can handle the max detected faces, which can set to, I think, any number, but at a certain point, your machine is not gonna be fast enough to detect all those faces. And there's this fast mode, which can be true or false. It basically is about the speed of recognizing. So, and you get more features if you do not use the fast mode, so you get more data from the face, and otherwise it's more of a narrow version you'll get back. So now we have this face detector called, and now we can detect some faces. This is everything that you need. So now with this detect function, you get back all the faces that it finds with that API. This slide and the previous slide are the only things that you need from the API. All the other slides will be functions added to do something with these faces, because we need to put in an image, as you see. We need to do something with the faces, because now we got a function which has all the faces, but what do we do with it? So let's say I have this, this picture, and you see a face, and the face has eyes, has a nose, has a mouth, has a boundary box of the face. For it to properly get the feedback, you see it detects those landmarks that are called landmarks, and they are displayed in this type of object you get back. That is that faces object that gets returned from the detect faces. So you get the location of the points for a particular type of landmark. So here you see some of the points from the right eye. You're seeing here the right eye. One of those points is detected, and it's in here. So that's that whole line that surrounds the eye. So you get those points back on a 2D plane. So it's starting at the image axis. So it's going from for you top left, and then moving up and down. And you got those values back, and you can do stuff with them. So first of all, we need to prepare the image. So I created a simple image tag and imported an image. Now I need to create this new image to get a bitmap from it. And with this, I need to add some functions to make sure it works. I'm checking if that face detector is available. Otherwise, when you don't have that feature flag, for example, enabled, it will give some errors, so you want to know it's there. And after that, we can check if the images are there, so we know every data is available. And after that, we can just detect the faces, and with what comes back, we can do that stuff. So these steps are needed, to get the image ready to put into the detector. That will result in these kind of landmarks. But as I showed, this was only getting the image into the detection part. We still need to do something with those landmarks. So what happens next? We need a canvas, because on that canvas we are going to create the lines. The canvas needs some styling, because we need to display properly, so here are some styling, so the canvas matches the image size and the image itself. And with that, we're going to initialize some things. So here you see some parts where we initialize the image, but also get the element and do something with glasses. We'll come to that later. With this, we're going to also need to do some math. We need to define the scale, for example, of the image, because that bitmap may have a different size, so we need to set all the properties right. After we've done that, we are going to render everything into the code goes here. So this is the canvas. Sorry, this is the canvas where you get the 2D context back. You need that for rendering those points back into the canvas. When you have that, now we have this faces part where I can have two functions where I can apply something with those landmarks. I've created those functions, and we're going to look at that. First of all, from this part of the code, with those functions called, I got this glasses on the picture. It's still a static picture, but it's still fun to do. But how do I get the calculations for those glasses? We'll get to there now. I did some magic. So I needed to get the average coordinates of those landmarks, because, like you saw, it was this big line with this amount of points, and I need to get the average of all those points, so I know what is the middle point of my eye. So I got that part. Then, maybe it's a bit small to see, but I need to filter out the landmarks, because I needed the eyes. Sometimes they mess up the eyes, or they just name them eyes instead of eye left and eye right. So I need to filter that out, so I know which part of the coordinates match those landmarks. After that, I'm going to find some math on the internet on how to find some right distances from 2 points, how to scale everything properly, and put all those values back into the SVG. And with that, I apply some things. So I draw the image, I draw the rotation, and now I have those glasses rendered as an image inside that canvas. With that, it shows that image on my face. So let's see how that looks. I'm going to open my local host. I'm going to move the Chrome browser back over. So here I have an example. And this is Albert Einstein. Just sometimes need to refresh the page. Here it applied a face filter with the glasses on top of the face of Einstein. Now I'm going to show you the code related to it. So move back over, get my code over here. Let's zoom in a bit, not too much. So I have this still image for now. This is the code I've been showing. So over here at the bottom, you see some styling happening. I have the image and the canvas over here. And with that, I do some stuff. So, like I said, I get all the elements. Now I open up the image of Einstein, which is person 2 in this case. And I created some config so I know what things I would like. So I create all these scaling and all the things happening over there. I detect the faces, and I had this field function where I applied the landmarks to it, and I was able to update this bottom canvas, which is on top of the image, to show these specific elements. So with that, I have this person over here. Let's go to public persons. I just have this list of person, just a plain image of Einstein. Let's get back to this image thing. I created these configurations where I was able to easily choose which thing I would like to put on top of the image. So now I have this glass over here. The glasses are, again, just a cutout picture of, I think it's over here. No, it's media and then glasses. So it's over here. I had those glasses. It's just a transparent picture of those glasses, so that gets rendered on top. With that happening, let me show you this part where I draw the landmarks. So now I had this function where I just draw the outline of those landmarks. It's basically just creating a line, a stroke, from every point to every point of those landmarks. And now I was able to see what it detects. So now when I switch back to my Chrome, not to this. If I refresh it, sometimes it needs a hard refresh. It did not update very well. So I think I need to save it before I refresh it. So over here, you now see it detected those landmarks. So you see the eyes, the nose, and the mouth. And this is where I use those green lines to get that average to apply the glasses on it. This could be extended into other elements as well. So I also have, for example, this video snippet, which I used before. It's just a recording of myself, and I put that recording into a video element. So when I open this, it's basically the same thing. It's only showing this video element with a pre-recorded video. After that, I create a regress frame animation, and I'm able to detect faces on every frame of the video, and then render the frames into the canvas. So when I open this to check, yeah, it's there. So when I now switch over, this was actually the camera. This was the last one I wanted to show, but let's see this one first. So with a pre-recorded video, you can also do it with a live recorded video. So it's now using the webcam of my laptop. That's a different part where you use a certain element where you create you get the user media. It's another API, a web API, where you get the media from your device, so from your phone, from your laptop, and I'm putting that image right into that video element. So with that, I'm able to use the video of my webcam to live detect the landmarks of my face. It had some trouble with the glasses, so for now, let's turn off the landmark part, because for an AR filter, you don't want to know where all the face or the eyes are, the mouth is. So now the lighting is a bit different, but over here, now I have my glasses on. It also moves, it follows my eyes. It's a bit janky because now it takes the average of every frame. You are able to take the average of multiple frames, and with that you are easy to just smooth it out. It is able to turn somewhat, so it also does that. And it stops detecting at some point. So This is very fun, where you can also do this live, with, for example, when you take a picture using your device. And the last thing I wanted to show, which is basically the more easy version of this, where you have this pre-recorded video. So this pre-recorded video, and over here it is also detecting the faces real time. So I do the same thing, where I have these glasses again, and I'm just putting all the data into that video element. I'm also recording it here, so I can export it with the glasses on. Let me get to the part where I apply the images. So here I have that draw landmark function I created again, which I can turn off. So now it's only showing the glasses, and I can go back and stop adding the glasses, but only show the landmarks, for example. So this is the data where you can go wild with. So you have the eyes, the mouth, the nose, and you are free to do anything with that. It's nice that you have this very small part of the API, which you can use to get the landmarks. And from that, you are able to do more stuff with it. This is just one showcase. I think, which is nice, that you are able to do something with it, with just some lines of code, some calculations. And if you show this on my birthday, for example, like this is what I created with just some text and numbers. I think people can be amazed that, yeah, they know these stuff from social media, know how those filters look like. But if you are able to recreate them just yourself, that's really great. So with that, there is this fun part of coding, this is maybe less functional. There are possibilities, use cases for it, but definitely with a feature flag right now, it's not that useful in production. But this is where that fun part interests you. This passion about getting code to do fun things helps you understand more and more what the subject is about and how the coding works. And that passion for problem solving, for creating something with code, that can go together with fun. And some things don't make sense other than just being fun, just being nice. And that is the fundamental thing of passion, I think. And when you let that mental part go, then that's where the fun starts. If you stop thinking about it, just have fun with what you do, then yeah, that helps being excited about things. So thanks for your attention. This is some of my social media, and I'm going to invite Caroline back onto the stage.
That was great. Do you want to join me?
Yeah, of course.
In my fake living room? I also loved, I don't know if y'all saw it, but like the stop please was very nice in your code. You are much nicer to your code and computer than I would ever be. But I appreciated it. All right, we got the questions. So first question up. Can this API handle a stream and not just a single image? I would guess yes, because of the videos.
Yeah.
But maybe if it's changing faces, there might be limitations.
Yeah, you especially have the problem with multiple faces in the stream, which you have in a photo as well, but then it just picks one of them. And in a video stream, if you have multiple faces on it, it has a hard time for every frame deciding which face to pick. So it goes more over the place and randomly picking a face for every frame. So yeah.
I could imagine it also takes a little bit of time sometimes to detect the landmarks. So that might be a limitation within that. All right. So then, what could I use the face detection API for beyond AR?
So this is an interesting question. It can also, for example, be really helpful on know where on the picture, for example, the important parts of the picture are. Most of the time when, for example, people upload a profile picture, the face is the most important part of it. So you can now, for example, crop that picture more clearly with the face centered, for example. So,
Yeah, we've all had that where it like cuts you off on your eyes.
yeah,
Ugh.
or especially when you have this profile picture turned into a circle when you upload it. It's nice when you have it already centered in the middle
not your
of that.
neck.
Yeah.
Oh, that's great. All right. So you kind of touched on this when you were doing the video demonstration, but how well does it handle rotated faces? Have you tried that with images?
Yeah, so it has some threshold. So at a certain point, it's going to stop detect it, or the rotation doesn't match because it's turning the landmark somewhat. But you are able to add your own code to it to apply for detection. So, for example, what happens if you turn at a certain amount, it stops detecting and then starts detecting again. But you are able to compensate by, for example, turning the image a bit. So if you see the faces turning, you could apply a counter turn on the source image or video. So especially for a video, when you see the image, the face gets turned, then you would be able to compensate for that earlier on. So it keeps detecting the faces. Yeah.
Yeah, that makes sense. Have you noticed or have you tried, like, is it different for different landmarks? Like, I could imagine your eyes when they turn versus a nose, maybe it could be easier?
This helps where most of the general parts of the face are nicely separated. So when you have the both of the eyes and the mouth, you're really able to get a clear understanding of in what orientation the face is, for example. Yeah.
All right. So it is behind a feature flag, as you mentioned. Do you have any information on when people would be able to use it in production or maybe even other browsers?
Yeah, so right now this is in that progress state. They are also requesting for use cases. So when you go to the blog that Chrome wrote about it, they are also asking, give feedback on this, share things, what you want it to be able to do in production. Especially because the barcode scanner is already in production. I think this will get there somewhere as well. No really time estimation. I think the first thing I shared about this was over a year ago, almost a year ago, and it was still in progress at that time. So we all know how the browsers deal with these changes, and yeah.
Oh, absolutely, yes. For sure. All right. How well does it, you mentioned this a little bit in your first answer about the rotation and but how well does it handle multiple faces in images of videos? And do you notice a difference between multiple faces in images versus multiple faces in videos?
Yeah, so this is also where the hardware comes in, because it's also depending on how fast your device is able to process these tasks. I haven't tried this with a really big group, but 2-3 people on screen or in camera view works okay. Especially if you turn, for example, to fast mode. Yeah, you get the 2 points of the eyes. Yeah, you don't need the whole outline of those eyes. So that can already be very helpful. Yeah.
And you can make it so that, can you make it so that different people have different filters, or is it mostly just the same? Like we'd all have glasses.
No, this is where your own programming comes at play. So you would be able to, for example, on the image, give every face a different glass of a different item you put on that face. In a video, you have this same problem where it just returns faces it knows, and the order is not predefined. So you have a hard time then distinguishing those faces. Although I think if you are well enough skilled in your math skills, then it might be possible, because the size of the eyes and the distances are also always a bit different per person, but then you are approaching a whole new aspect of this.
Oh, absolutely. And if people are moving around and switching directions in the videos, I could imagine you'd have to have very good math skills. All right. So can we use it in extensions so we can detect that employees go to the toilet instead of working? That sounds like a That sounds illegal. But let's say there's other examples.
Yeah, so this is also part of your own creativity, where if you have a way to use a face detection, yeah, it would be possible with this just based on those landmarks. So you are able to, for example, tie this to a camera feed you have somewhere set up and just see if there are faces there. So if you have, I don't want to encourage this employer, but for example, if you have this security camera, you want to know if a person passes by, you are able to match this to if you can run it in this Chrome browser, you are able to detect if there is a face on that camera. Yeah.
This is why everyone should have a webcam cover. Like, these are the exact reasons. I don't trust anyone.
Yeah.
All right, and then real quick before we end, so a lot of what you showed was 2D, like the flat images. What about 3D?
Yeah, so this is a bit more tricky because 3D is a whole different level. These glasses were now really flat. If I turned my head, they still stay the same size. They correct for rotation, but not for the depth rotation, the skewing. This is possible, only you need to do the calculations based on the distance of the eyes compared to the mouth and nose, for example. Yeah, but it is possible to also stick to Z rotation. Yeah.
Amazing. So that's all the time we have, but thank you for having this chat. And please, can you give it up for Jorrik again?
Yeah. Thank you very much.
All right, so Jorrik will be available if you're remote in the spatial chat, and then also now